And so that's what we're going to do in the rest of this talk. Not deal with statistics and small probabilities, but find out if we can find the next impactor before it finds us. And we call this the Space Guard Survey. If we look for the survey and find these objects one at a time and calculate their orbits, then we can provide decades of warning. Of course, if we don't look, we'll be just like the dinosaurs. So the first step is an astronomy step. It's to get telescopes and look for these objects so we can find the next one before it hits. And let me just say, there's an analogy I think that's useful when you talk about this shift in perspective from statistics to actually searching for them. If you are foolish enough to try to jaywalk across El Camino, for instance, I doubt very much if you ask yourselves, what are the statistics on pedestrians being hit crossing this street? I bet instead you look to see if there's a car or truck coming. And that's what I'm saying we should do with asteroids. Let's look and see if one is coming. The Space Guard Survey began operations 10 years ago, 1998, and it's based on relatively small telescopes, just a meter in aperture, but with very sophisticated detectors and computers. In fact, the computing power to support the Space Guard Survey didn't exist before the mid-1990s. The goal, which has been established by NASA, is to find 90% of the near-Earth asteroids larger than 1 kilometer diameter by the end of 2008, which is within 10 years of the start. And 4 telescopes have done most of the searching. It's a completely open operation. Every clear night they're observing, and they process the data within 6 hours, and by 3 o'clock the next afternoon they're posted on the Internet. And so you can look and see each day how many asteroids are observed, how many are discovered, what their orbits are, and make your own conclusions if you want. But of course, part of the process is to filter through these data and find out which orbits correspond to objects that could hit us. Let me say one thing very clearly. Only in Hollywood do asteroids change their orbits capriciously. It's a wonderful plot thing that a comet or asteroid suddenly gets knocked out of orbit and heads for Earth. But in fact, it is a very deterministic thing. Newton's laws really do work. The same thing that lets us send a spacecraft to Neptune will let us predict an asteroid impact decades or centuries in advance once we find it. So we don't worry about anything changing. We just want to do this survey and see what's out there. I mentioned this, maybe I'm being defensive, but we constantly get questions raised, things I call myths, about the survey. They say, oh, but your telescopes don't work at daytime, they only observe at night, so aren't you going to miss half the sky? They say, but your telescopes are only in the northern hemisphere, so you're not looking at the asteroids in the southern hemisphere. The point, of course, is that these asteroids that are going to hit us will come by the Earth thousands of times before they hit. And if we miss them this year, we'll get them next year. We just want to have a maximum throughput on the system. Another thing, very strange, I guess people don't look at the sky very often. They say, but a ground-based telescope can't look at something in the direction of the sun, something in an orbit inside the orbit of the Earth. How many of you have ever seen Venus? Bright against a dark sky. Venus has an orbit way inside the orbit of the Earth. Only 7/10 of the distance from the sun we are. We can see it just fine. In fact, we can see it better with ground-based telescopes than space telescopes. The Hubble can't really look that close to the sun. So the bottom line is it really doesn't matter whether you look from one site or many, northern hemisphere or southern. You just want to maximize the throughput of the system. What you're doing is photographing a patch of sky, doing it again 30 minutes later, again 30 minutes after that, looking for the faint moving asteroid against the tens or hundreds of thousands of fixed stars. And given time, you'll find them all. If you don't get them on this pass, you'll get them on another. You probably know the story. I think it's always amusing to talk about throughput. When the Berlin airlift started and we were desperately trying to fly enough food and coal and goods into Berlin, the planes just took off one after another and flew into the airport in Berlin. And, of course, sometimes the plane will miss its landing. There'll be a little fog or it will not come in right. And any pilot would say, of course, if you miss, you'll come around and do it again and land the second time. But that stopped the whole string of planes coming along behind. So they adopted the rule, if a plane misses its landing, it turns right around and flies all the way back to West Germany and gets in line again. Because you want to maximize the throughput. And that means you give up individual things. If we see an asteroid and lose it, we don't worry about it. We don't divert the telescopes into looking for the lost asteroid. We go ahead and try to get the system to work. And it is working. Here is the record of discoveries. These are total. We now know almost 5,000 of these near-Earth asteroids, the ones that could hit us. And of the big ones, more than a kilometer, we're coming up there. But can you see that the curve rolls over? We aren't discovering them as fast as we used to. Why is that? Have the astronomers become lazy? Do the telescopes not work as well? No, the point is this is discovery. You can only discover an object once. And that's in the catalog. What the telescopes are doing now is rediscovery. The majority of the asteroids found every night by this automated system are just rediscovery of those we've already had for the big ones. And that just proves the system is working. In fact, as we get nearer and nearer to completeness, we'll find out we're less and less efficient. If we want to change from this size asteroid to the much, much more numerous small ones, then we have to go to bigger telescopes. That's what I call the space car deep survey. You don't just build more little ones. You take a whole big jump into what is called the Large Synoptic Survey Telescope, which is a horrible name, and I hope pretty soon they'll name it after Newton or somebody, and so we can call it something better. But this has been recommended by the National Academy of Sciences. It's going to be built in the next 5 years in Chile. And it's going to be the astronomer's dream telescope for throughput. Wide angle, deep observing. It can observe the entire sky down to something like 25th magnitude in 2 weeks. And do it over and over and over. It will give us Universe the movie. And it'll be available, we hope, on your home computer. So you could pick a little patch of sky you liked and watch it over and over and see what things were happening, what was changing, what was variable, whether there was a gamma ray burst, and in the process, pick up these asteroids. Well, Congress is supporting that. And at the end of 2005, they did two things. They not only asked NASA to look into working with such new telescopes to go to much smaller impactors, they even changed the basic legislative charter of NASA to give it responsibility to resolve any ambiguity about what agency was supposed to be in charge of dealing with asteroids. So they asked for another study, which I did not chair. It was done at NASA headquarters and was just released a few months ago. Actually, it wasn't released. It had to be take a Freedom of Information Act request to get it out. And it talked about a lot of things that one could do. It had 271 pages. But in the end, the response to the Congress was that NASA doesn't have the funds to carry out this survey. And some members of the House of Representatives weren't too pleased by that. And the fact is that next week is a hearing in Washington to examine the NASA report and what it means. Let me now conclude by talking about planetary defense. We don't do this just because it's fun, although it is, to find these asteroids. We do it because if you find the asteroid with decades of warning, you can do something about it. It is the only natural hazard that we normally deal with for which that is true. Here we sit. How many miles from the San Andreas Fault are we here? Not very many. And we know those two tectonic plates are continuously moving with respect to each other. You can use GPS to do it. There are lots of ways. The Pacific and North American plates are moving along at about the same rate at which your fingernails grow.